thank you very much for the to the organizers for the opportunity to speak with you, and thank you all for attending. I'm very grateful for that. And like Ibrahim said, um, I'll be sharing with you some insights from my own journey. I have to disclose at this point that I am an engineer also, right? So I'm originally an electronic engineer, electrical and electronic engineer, and then my master's was in agrometeorology, not exactly an engineering discipline. And then my PhD was in agricultural and biological engineering, right? So I drifted in the direction of agri-food systems over time. And that was quite a while ago. And things are far more dynamic now. So hopefully, the material that we're going to share today will inspire some of you to look in other directions as well, and set things up for yourself to look at new opportunities. So briefly, what I'll be talking about has a grounding in the UN Sustainable Development Goals. So uh, what what we'll be talking about will be motivated by that in no small part, right? So let's continue. Our goals here today: introduce some basic ideas of ICT, of AI, and standards, and contextualize them using an example, which um, is the one I know best, which is agri-food systems. Along the way, um, I will plug ISO TC 347 that our presenters mentioned earlier. Discuss some tension between different development approaches that we see in, for example, the African continent, um, between ideas like appropriate mechanization and ICT and AI and hopefully standards heavy leapfrogging approach. And we'll discuss the relevance of all of this for you and what it means for example, food security in Nigeria. And then hopefully you will be inspired to look deeper into international standardization efforts and will want to participate in, for example, the ISO system. Hopefully, in the efforts that I'm a part of, but there's a lot more in ISO than that. So um, I think that it's great when we're talking with people that we don't know yet, and we're trying to establish some basic parameters for a conversation. To start with a Venn diagram. So let's put a blob there for information and communication technologies. And let's dig a little bit deeper into what that means, just so that we're sure that we're talking about the same thing. Okay? So um, generally, the term ICT is accepted to mean a set of technologies that, when combined, allow um, different agents, people, organizations, um, equipment, to interact in the digital landscape, right? And we've got things like software development, which is changing enormously these days as large language models uh, really are changing what software developers do, right? They're moving from writing every single line of code to tell a computer what to do to being more like um, editors, shepherds, if you will, of uh, work that's being done in no small part by an AI-driven agent. Hardware is changing, right? There's um, an enormous demand for very fast um, hardware that can drive the um, huge computational demands of artificial intelligence in an energy efficient manner. right? There's an increasing amount of e-commerce. So systems that can support transactions of multiple sorts, um, and including capturing records of things that aren't necessarily commercial, but might be related to, for example, food traceability or things like that. That's only growing. Of course, we have the communications technology aspect as our communications engineers find um, newer and better ways of moving data wirelessly. Um, of course, we have aspects about representing data and making it available, internet access, of course, and last and perhaps the greatest now is cloud computing, which is definitely the way in which most people are now implementing new systems, having a component on the cloud, right? Also want to acknowledge, you'll see that there's some links when I steal somebody else's graphic because it's really good. You'll see the link there, and usually there's a really great article on the other end of the link that I would encourage you to read afterward. And of course, I will make these slides available, right? And I don't. Am I really not that audible? Can you guys hear me? I see there's something on the chat to that effect. Can you hear me?
Yeah.
You can?
Yes, actually, we can hear you, sir. But maybe,
We're hearing you.
we
We're
can just
hearing
increase.
you.
Yeah.
So it's not too soft?
Yeah, please, you can just increase the volume a bit, sir, if you don't mind.
Let's see how I can do that.
Yeah, with your voice,
Volume.
actually.
Okay, is that better?
Yeah, it's better. We can hear
Yes,
you
it's better up now. We can hear you better.
Excellent. Thank you for bringing that up. I appreciate it. So let's continue here then with our next slide. Well, just reiterating, this landscape changes quickly, right? And these 7 different technologies are changing daily, and there may be new things that we're not seeing. So back to our Venn diagram, our little blob, right? So we have that little wheel associated with ICT. We're also wanting to talk about AI, right? So let's make that be another blob, which is mostly overlapping ICT because the different aspects of ICT are so involved in AI. But I just want to mention that there's some things about artificial intelligence, such as the ethical concerns behind it and regulatory concerns and so forth, that aren't necessarily covered in information and communication technologies. But let's dig a little deeper into artificial intelligence and the technologies involved there. First of all, we have all these sort of legacy things that used to be an important part of what artificial intelligence was before, many of which are still very, very relevant, right? So we have things like knowledge representation, which is even bigger now than it used to be. It's a fundamental to represent knowledge in a way that we're going to be able to use effectively, whether it be to support reasoning or to support different forms of machine learning and so forth. We've got natural language processing. There were some classical approaches to that, and there are some new ones as well. Expert systems, where through the use of a sequence of rules, the expert knowledge of someone can be captured and operationalized as a way to solve problems on an ongoing basis. They're still used for many things. Then we've got robotics, of course, and computer vision that have different applications, multiple applications, of course. And fuzzy logic was more popular a few years ago, but the idea of dealing with uncertainty and trying to represent somewhat unclear degrees of uncertainty in data is still quite valid. But what we're mostly going to think about now is machine learning, which is all the rage lately. And we've got three kinds of machine learning, which are supervised learning, unsupervised learning, and reinforcement learning. And can you still not hear me very well? Because I see that there's some additional notes there about that. Let me switch to a different one. Is this better? I've got three different microphones, so let me know if you can't hear me.
It's fine, we can hear you.
Okay.
Yeah, advice, if they can get headphones, earphones, I think they'll get better. That's fine, sir. You can go ahead, sir.
Okay, so you're telling me this is better? Okay.
Yeah, yes, it is. Thank you, sir.
Okay, good. So we've got these different types of learning. It's supervised learning where you're giving your algorithm a set of data and answer responses, right? So if you're trying to establish some kind of function between a set of inputs and a set of, and an output, you give it many examples of the data and the result of the data, and then your algorithm trains on that data set to be able to reproduce those results. And there's a variety of ways of doing that that range from really old ones like supervised learning, like regression and classification trees, to multiple regression, to multiple other methods. Then in unsupervised learning, what we have going on is that the machine is trying to infer patterns, looking for patterns in the data, and trying to figure out what we want without the benefit of a set of input-output combinations. And reinforcement learning is similar to these two in that they're that it's trying to produce a mapping between inputs and outputs, but it's driven by a reward system. So when it produces a good result, you give it a reward signal that then reinforces the pathway that led to that result. And when it produces a bad result, you de-emphasize it, right? Now, a technology that's used for quite a lot of this work is neural networks. That was one of the classic ones. It could, if machine learning wasn't such a big deal now, it would just be among that list. When I studied artificial intelligence in grad school over 20 years ago, it was, expert systems, fuzzy logic, neural nets, knowledge representation. Those were the big topics. But now neural networks is part of machine learning. And then we've got the idea of deep learning as well. And these things are have a significant overlap here. And among that overlap, we have a domain called deep neural networks. And I've led some projects on in this space to resolve or solve some agricultural problems and have gotten really good performance. We'll talk a little bit more later about what can ensure that you get really good results when you're trying to solve practical problems with artificial intelligence. I guess I'll give it away right now. And it's trying to choose your problem carefully and try to simplify the problem as much as you can and try to put in ways to check and contextualize the result to the best of your ability, right? And as Ibrahim is saying, please feel free to ask questions along the way, right? I will be more than happy to pause to talk. We've got other subdomains there, like convolutional neural networks. Then the newer approach of generative AI, and there's several subdomains in there, like variational autoencoders, generative adversarial networks, and the darling of the moment are transformer-based language models. And you have no doubt heard and hopefully used ChatGPT, which is a tool in that space, right? So there's a lot going on in artificial intelligence. There's a lot to learn. There's a lot to do. There's many ready-made or nearly ready-made solutions that you can adapt to your needs quite readily, including some open source models that are making their way out there that you can use. There are, of course, some ethical concerns, right? So if we go back to our Venn diagram of earlier, remember, we've got these ethical concerns that go a little bit beyond ICT, right? Concerns like what happens to the data I feed large language model in the cloud. Does it still belong to me? Does it belong to them? Right? Those are the sorts of things that we have to ask ourselves and be very careful with as time goes by, right? Because you might find yourself developing intellectual property as you go along using a large language model tool online, and then find that your intellectual property has actually been baked into that model later, right? But the examples I'm looking for today are primarily from agri-food systems. That's where I work on a daily basis. And by agri-food systems, we're talking about growing crops, whether it's for food for humans or feed for animals or fiber fuel or specialty crops like flowers, things like that, or medicinal crops, or whether you're raising livestock or processing a crop or animal products or manufacturing food, or whether you're dealing with crop inputs like fertilizers or chemicals or seeds or water, or whether you're dealing with your supply chain for all of the above. And we'll talk a little bit more about the supply chain in a moment, but in the meantime, let's look at some of these regions in our Venn diagram. Here in the intersection between information and communications technologies and agri-food systems, we have a whole category of software products called farm management information systems that help people manage their agricultural production. And do things like help you calculate your costs of production, help you schedule the use of your resources, help you keep track of how you're growing your crops or what you're doing with your animals and be able to provide that information to regulators or to business partners and so forth. Then you've got some spectacularly successful applications of ICT and agri-food systems, like, for example, auto steering of tractors and other agricultural machinery. Other classic precision agriculture technologies like variable rate application, where you go and you measure, say, the fertility at different points in the field. Then you use spatial interpolation algorithms to give you a map of the fertility you have for or the concentration in the soil of different nutrients. And you look at past yield maps that show you how well your crop yielded over space in your field. And then you calculate site-specific yield goals with the nutrient concentrations that requires, and you calculate the gap between what you have in the soil and what you need. And therefore, you go and add that amount back to the soil, right? But to make it available for the plants. So all of those are applications from this intersection right here. Another interesting intersection is the intersection between AI as part of ICT and agri-food systems. And there is a lot happening here right now. I'm starting to see really interesting chatbots, for example, that are interactive tools that can really expand the reach of an agronomist or extension agent by tackling a lot of the sort of low-hanging fruit, speaking agronomically, and provide advice while at the same time maybe realizing that a question is too complex to be answered directly and needs to be passed on to the agronomist. It's very typical in developing countries for there to be a lot of smallholders and not enough trained human capital to be able to provide agronomic advice to all these people. So chatbots that serve as a first line of defense are extremely useful for the agricultural development of those countries and directly food security, right? Identification of pests and disease IDs. Same story, right? There's climate change, there's new pests that are present in different agricultural ecosystems as a result of just migration, species introduced through international trade, just different climate conditions that make it different or more feasible for a pest you haven't seen before to get a foothold in your area and so forth. So farmers are seeing pests that they haven't encountered before. So having a tool on their phone that can identify that insect or that disease and suggest a course of action is extremely valuable. So that's a very hot area right now.
Hi, and can I ask a
Yes.
question here? Right.
Yes.
So I've been in several rooms where there's this ongoing debate about whether the I won't say third world, the global south and less industrially developed countries should focus on mechanization, typical just to increase agri output as compared to AI investments. So where would you stand in the, either or both debate? Do we focus?
I
one.
very much have an opinion about, you know, whether the global south should focus on things like appropriate mechanization or try to leapfrog and burn stages through the use of ICT and AI, right? And you can probably guess what side I stand on here, but let's leave a little bit of suspense here for a while, because I do have a slide or two about that. Okay, so just hold that thought and we'll get there in a moment. Okay, the fact is that those farmers who would be interested in appropriate mechanization or in digital tools or what have you are having a harder time farming than they did before. Farming involves hundreds of decisions per crop season. And it is complex for the biggest farmer, and it is complex for the smallest farmer. Problem for the smaller farmers is that they're more vulnerable. They have less resources at their disposal. They probably can't afford to have a really, really bad year. And they don't have access to things like risk management, finance, advice, and so forth. In the past, their decisions were often driven by traditional local customs. What mom and dad did, what, you know, your grandparents did out on the farm were likely what you were going to do, and it was going to be okay. But the world is changing very rapidly. It doesn't rain when it used to rain. Like I mentioned, there's new pests. Fall armyworm is just eating its way through Africa right now. It's terrible. So in that context, decisions increasingly have to be made based on data. And there's a great opportunity to make a difference here when you're a country in the global south, right? So I'm starting to this is a teaser about the question we just talked about, right? Which is what should the global south just stick to appropriate technologies, or is there a way to make these newer things appropriate? Well, let's keep going. So I mentioned the supply chain. Let's call this big arrow here the primary agri-food supply chain that goes from the manufacturers of crop inputs, like say Syngenta, BASF, Bayer, all those, or a local seed company or whoever, right? They manufacture the crop inputs. Then you have a distribution channel for those. And then you have somebody who's selling it to the producer. Right? Then you've got the farmer, then the folks that buy the commodities harvested or products harvested by the producers. Then you've got folks who process that, package it, and then distribute it and sell it to people. And then they have their dinner plates. These different actors on the primary supply chain are exchanging data constantly as part of their business transactions. In an increasing number of jurisdictions worldwide, this is requiring what's called one step forward, one step back traceability, where you need to keep careful track of what you bought and who you bought it from, and what you sold and who you sold it to at the sort of lot or batch level, which brings an important burden to these different actors, many of whom end up needing advisors to help them make some of these decisions. And those advisors require data to produce trustworthy advice. So there's more exchanges. Then, since quality is an important aspect of food and the just bioeconomy in general, test labs are often involved. So most, if not all, of these different stakeholders exchange requests and results with testing labs. That's a significant source of friction right there, dealing with different formats and so forth. There's data exchange with equipment dealers. So the people that sell you equipment. Sometimes you've got telemetry data going to those dealers or going directly to the manufacturer. They might have a cloud where data from your machine is going, and then you have to pull it from there, right? There's complexities associated with that as well. Then there's a very wide variety and growing number of service providers. Give you weather data, soil data estimates, evapotranspiration estimates, remote sensing providers, financial advice, a variety of things, risk management instruments like weather derivatives or crop insurance. And of course, they're regulators who most of these actors have to exchange data with in some form, right? So this is a huge web of data exchanges that are taking place in our agri-food system. The problem is this doesn't work very well for small producers, smallholders. They produce, depending on who you ask, between 1/3 and 1/2 of the world's food supply. And yet they're typically outside the system. So a big question is, how do we integrate them? If we care about the SDGs, we have to care about how we integrate smallholders who are primarily concentrated in the global south so that they can use the technologies available and help drive the development of new technologies to bring them on board so that they can derive value from all these data exchanges. Now, the problem is that these data exchanges are hard enough. These data exchanges are hard enough even for the bigger players. So it's extraordinarily difficult for the smallholders. So why do I say that it's hard even for the bigger players? Because as the amount of data that we need to make decisions grows, the number of data sources that we need to involve is growing also. And each one of those data sources is typically using their own application programming interface. They have their own web services with their own data format, their own set of codes with which they express things like the crop that we are talking about, or different, variables like temperature or soil water content or humidity and so forth. And typically, it falls on the data consumer to deal with all of these translations between the language of the data producers, and there are multiple forms, and a common language that the data consumer can use in their farm management information system or whatever digital tools they want to use. Or even if they're just working manually, this translation of data being focused primarily on the shoulders of the data consumer is typically overwhelming. It's just impossible to scale. So what's the alternative? When we have data standards that can be adopted by all of the actors in this ecosystem, and they all speak the same language. So as long as each one of them of the data producers can write to the common standard, and as long as the data consumer can read from it, then creating data-driven tools is much easier, because you can fuse data from, say, different weather providers. You can take temperature data from this station that you have on your farm, and temperature data from some gridded service around you, and mix them and use them together and so forth. This is very important, the power of standardization in ICT and AI and data-driven agri-food systems. So let's go back through our chart, right? And let's introduce standards here as a very large shape. Why is it so large? Well, because there's standards for everything. There's standards for welding. There's standards for the tires that you put on your automobile, and the spark plugs, and so forth. It's there's standards for everything. ISO alone, the International Organization for Standardization, which is one of several international standards organizations, perhaps the most well-known, but ISO has over 25,000 standards, right? So it's a very big shape. And in the intersection between it and ICT, we have many standards. We have standards from ISO related to things like representing time, representing many things like supply chain documents and so forth. But we also have from the World Wide Web Consortium, W3C, a lot of what we see now on the internet and the way that the World Wide Web is assembled is built on the stack of standards from W3C. We have standards from the International Electrotechnical Commission, IEC, that have to do with the electrical aspects of what we do, and so forth, right? So there is a plethora of standards pertaining to ICT issues. There's also standards that have to do with agri-food systems that aren't ICT specific. Things that have to do with food safety and traceability, with the properties of different products like starches and rice and cassava and palm oil and things like that. There's a multitude of those things. Safety on machinery and so forth. Now, in this little space, what standards are there that have to do with AI, but aren't necessarily linked to agri-food systems? Well, there is a very interesting one we'll talk a little bit more about called ISO 42001. It's a standard for a management system for AI, and it might be a great place to start looking. So we'll talk about that a little bit more. Okay, now, what about this big central space, this sort of curvy triangle? That's the intersection between standards, ICT, the AI aspect of it, and agri-food systems. What's happening there? Well, let's start by maybe looking at an example of a problem, which have been called the middleman problem. It's a global south setting. We've got cassava farmers, they invest in growing crops and bringing them to processors. However, when they get there, the processor raises issues about the product and says, no, this cassava is too big, this cassava is too small, I don't like the color, this bitter cassava, but I wanted sweet cassava, etc. And then the farmer is only offered a fraction of the price they'd been initially promised. So what's the fundamental problem here? One is transparency, the factors that determine prices and the scales that sort of manage that quantitatively are not transparent to the farmer. And farmers often settle for reduced prices because they've got these sunk costs and a lack of alternatives. So they don't know of an alternative place to sell their stuff. So if we had a standard or standards that could help here, what would success look like? Well, farmers have phones. Depending on where you are in the world, they might have a smartphone or they might have a feature phone. Their data plans might be relatively inexpensive or they might be prohibitively expensive. So there's a lot of variability in that space. But the fact is that they have phones. So providing information and about market conditions and how to set market prices, and also information about clearing houses that can provide alternative destinations for a crop, especially if that crop has a story behind it, would be quite helpful. It doesn't change the situation where, I don't know, the farmer only sells to, or can only sell to somebody who comes with their truck down a muddy track to the village and there's nobody else that will do it. Certainly that those sorts of situations aren't necessarily helped by the availability of greater information, but many others are. Let's talk about a second example, which we call the machine data problem. In this case, the setting is you've got an agronomist, so a service provider. They provide precision farming services to farmers along the lines of what we talked about earlier, right? Which is you have some planting information from past yields and soil fertility data, and then you can make suggestions about the best way in which a farmer can use a limited budget on crop inputs like fertilizers, seeds, and chemicals to grow the best possible crop in the most profitable and sustainable and compliant way. It's a great idea. Farmers shouldn't necessarily have to deal with all of these things by themselves, right? You don't, do surgery on your own brain. You don't necessarily build your own house or fix its electrical system when something isn't working, in the same way that you call a professional to do things like operate on your brain. It's reasonable to expect that you could call on a professional to help you with complex data-driven aspects of your farming operation, right? But there's a problem, which is that since each equipment manufacturer and data provider, as we've talked about earlier, has their own format or data dictionary, so the set of codes that they use to represent different things, data translation is very difficult. And so then, as a result, the agronomist spends so much time per hectare cleaning and preparing data that the business just isn't sustainable because the service prices per hectare are just too high. So the business fails. So what would success mediated by standards look like? Well, if different manufacturers can use the same standard or provide tools to readily convert proprietary data format to standardized forms, that would be great. Now you might ask, why would a manufacturer do that? If they have a good market share, why would they want to actually make it easier to interoperate with their competitors? That's a very real question in agri-food systems or in any other industry. And typically, I'd say the answer is that there's no stronger force than an angry customer, right? So when those calls start rolling in, where a customer says, man, I'm trying to use your equipment. I'm trying to use your equipment. I've been a loyal customer, but I just can't use the data, and I need the data because we have to make decisions based on data now. Things change when there's enough of those calls. So customers have more power than they think. And I've been on the other end of a call from a dominant market original equipment manufacturer that called me up and said, we have to integrate. And I said, why? We've been trying to integrate with you for a long time. I say, well, we have to integrate and embrace a standard because I've got too many big customers that are demanding it. So tell me how to do it real fast, right? So that's an important force. Another success mediated by standards would be that agronomic tools are readily accept the standard data format, which is a good thing for data consumers. It's something that they want to do. And as a result, friction is reduced, efficiency grows, per hectare prices drop, and then the business becomes sustainable, right? And just a quick way of just giving you a sense of how these, in the case of machine data in particular, data tractors and combines and so forth, how they produce problems. Imagine that farm management information system. Let's imagine it has a cloud. Let's imagine the machine, the mobile implement control system. So the terminal on inside the tractor and the controllers associated with it. And then the field operations backend. So where you're going to process the data afterward. You've got these data flows going from the farm management information system saying, this is what I want to do, to what happens in the cab, to where the data that you collected comes back to you, right? So we can call this a work order where you're giving instructions, and we can call it a work record where you're being told what actually happened. Now in there, the operator typically has to manually capture changes to product rates, to who the operator is, to what product you're using, which is a big deal. Product identification is a big problem. And then during the field operation, you need to make sure that you know where you are, what the rate is. You need to have that calibrated. It's quite complicated, right? And at each step of the way, there's usually a pain point, right? There is complexity, there is friction, there are unhappy customers. This is a problem worldwide when people are trying to use machine data. So what do? Our industry's in a bind. Our standards aren't enough to support data-driven decision-making needed to solve modern problems, much less address the sustainable development goals. This is a result, as usual, from the bottom-up growth of both the industry and its standardization efforts. So ISO, the International Organization for Standardization, realized this and chartered a strategic advisory group for smart farming back in 2021 that I co-chaired with a gentleman from Germany. Had about 180 experts from 21 countries to come up with a strategy to help ISO know what to do about how to enable smart farming and the use of ICT and AI and so forth in agriculture. A key part of that proposed strategy was to create a new home for standards specific to data-driven agri-food systems. This exists now as of the beginning of last year, and it's called ISO Technical Committee 347, which comes to fill in that space. It doesn't fill it completely because there are other standards that have to do with agri-food systems and ICT that that don't fall in our scope, like some machinery things, like how the ISOBUS, as it's called, the controller area network in agricultural machinery operates. That's out of our scope. It's more in agricultural electronics. But data-driven, principled, multi-objective decision-making in agri-food systems and all the things that drive it are in scope. Okay, so some quick facts about it. The Secretariat, so the folks that do the day-to-day organizational work, are in Germany through their national standards body DIN. Sophie Oberländer-Hein is the committee manager that does all that paperwork. I'm the chair, so I'm more involved in the strategy and the stakeholder engagement, if you will. We have a web page. You'll get this with a live link in the slides, and we have a LinkedIn page, which is sort of the primary form of communication with the general public. So please feel free to scan that QR code and to follow that page to see various exciting things that are happening there. After 3 plenaries, which are the big meetings where everybody comes together, 2 of which have been virtual, and 1 of which was recently face-to-face in Germany, we've had good participation. But as you can see in this participation map, there's several regions that are underrepresented. Fundamentally, the global south, right? Now, a shining beacon of participation, because the darker color in this map represents participating members that have signed up to participate and help move things along. You've got Nigeria here. It's the only participating member in Africa. So a message to you is take charge, help move this along, make sure that the interests of Nigeria and the continent are fully considered in the work that's being done there. There's a strategy. DC 347 has a strategy. It's a rather complex set of interlinked strategic objectives, stratified between learning and growth, so things that we need to do in order to be able to do what we need to do, then establishing internal processes, then building up a set of standards that we can use as resources, like, say, enable field boundary management or enable smart spraying, things like that. And things that we want to enable for end users, like satisfied, well-informed, and engaged standards end users, more efficient and resilient agri-food systems, and of course, our ultimate goal of enabling the SDGs. An important point is that the strategy is determined by the folks sitting around the table. Don't trust folks in the global north, however well-intentioned they might be around that table, to fully understand your needs. It's important that you come to that table, right? And let me answer a question that you might be thinking about, like saying, why do we want to go through all this hassle, all these problems of joining ISO through a national standards body and so forth? Why can't we just use, open source tools, and there's some open standards out there that, would probably be good enough? Well, the problem is that a lot of international trade is governed by the dictates of the World Trade Organization. And the World Trade Organization strongly supports the use of standards to combat, barriers to trade. The idea being that if everybody's using standardized ways of operating and communicating, then barriers to trade are eliminated. The problem is that if you haven't implemented those standards and you're ignorant about those things, you de facto have a barrier to trade, right? So participating in that international system of standards is rather important from a strategic point of view for a country. So we come back to the question that Ibrahim was asking earlier. When trying to innovate, there's always this tension between caution and speed. There's folks that say, no, we need to go slowly because there can be interactions and unintended side effects that we ought to try to anticipate. And those people aren't wrong. But then there's other people that say we need to go as fast as we can because technology changes quickly. And if we have an opportunity for standardization and so forth, we have to use it whenever we can. Because standardization processes are currently slowing up without adding even more steps. We need to hurry up. Those folks aren't wrong either, right? And if instead of caution and speed, you talk about, appropriate mechanization, and you talk about, trying to move forward with AI and ICT and, hopefully standards, that question pops up again, right? And I deferred my answer to this question, right? And I think that the right answer is that you have to do both of these things. On one hand, the small farmers aren't going to go away by themselves, right? So something that can, or coming up with the workflows and the mechanisms for, say, local manufacturer of a lightweight, inexpensive, easy to repair planter that can help a smallholder plant their crop in with some mechanization, with this planter that's pulled by their family or an animal, versus poking a hole in the ground and putting a seed inside it manually. That makes a huge difference, and that has to happen too, right? So I'm not against appropriate mechanization in any way, shape, or form. I'm a fan, right? But at the same time, if you're always going to keep having that same lag, then the global south never gets to reap any benefits from new technologies. And by keeping the same lag, I mean, if you're just working on this bottom-up approach of working only to what the farmer can use right away that seems appropriate in terms of mechanization and so forth, you just perpetuate this lag, right? And the fact is that following the blueprint that was developed in the global north 50 years ago isn't a good idea, I think, because things have changed. A smartphone and even a feature phone where you have been able to install software because you have, say, an agreement with the telecom provider, those are extremely powerful tools. We've already talked about simple software, simple to install, not simple what it's doing, but software that can, for example, detect pests, detect diseases, or just estimate your yield by like counting your corn kernels and doing some calculations. Those things can live on phones. They don't have to use your data plan except when you installed it, maybe using Wi-Fi at your kid's school. Those things can really help close that gap. So I'm very much a fan of proceeding along both tracks. And curiously enough, in my technical committee, we one of the multiple things that we're working on is a proposal for a standard that can take innovations like, say, the blueprints for that planter that maybe somebody came up with and wants to share or wants to sell, right, to people that could manufacture it, and have a platform where these things can be shared worldwide. the world is full of innovation hubs and organizations like universities that want to help with technological development. Sometimes they do a lot of pilot projects, but when that money ends, the innovation ends up being sort of lost. So what we're proposing here is a standard for a federated platform for diffusion of innovations. I don't want to take up a lot of time here because we're running out, but take a look at this and ask me if you're interested. This is something that we think could be very relevant. As an example of the sort of material that that we're thinking about, here's a two-wheeled tool carrier that perhaps some of you have already seen before. This thing has detailed, readily available blueprints that exist in digital form, could be distributed easily in a way that folks could access through their phones from anywhere in the world. So let's skip this exercise. Let me tell you a little bit how to participate in Technical Committee 347. Most world happens online. And in fact, in any ISO committee or any ITU or IEC committee, typically most work happens online. We have 2 plenaries per year. One is virtual, like a couple of half days, and the other's in person, where part of the big plenary part where everybody gets together is online or hybrid. And then there's a lot of really exciting meetings that are in person. Now, someone might say, wait, but I'm from the Global South. I can't afford this. And the answer to that is, but ISO has a developing countries committee that has a mechanism for funding experts to go from different countries to these plenaries, as long as they're participating members, which, by the way, Nigeria is, right? We, at our recent plenary, we had an expert go from Jamaica, for example, through that funding model, worked just fine, right? So, so that's exciting. And there's 3 ways of connecting to this. One is through your national standards body, right? Which is SON in Nigeria, I believe. Another is through a liaison organization, like the International Society of Precision Agriculture is a liaison organization. I'll probably be talking soon with folks from the African Society of Precision Agriculture to say, hey, set yourselves up as a liaison organization, you know, take your seat at this table so that you can help drive things in a way that helps your member countries, right? And through a thing called IWA 47, which has a lot less overhead than participating through a standards body. It's not the same thing, right? Because you can't, IWA 47 means only indirect participation, TC 347, because it deals with a small part of the whole. But it's worth looking at to get a taste and find out how you get into the bigger picture. More about IWA 47 is it's what's called an international workshop. And it's sort of a bulldozer kind of opening up a path for TC 347. In a nutshell, what it is an agile and inclusive mechanism to provide TC 347 with the start of a reference architecture for data-driven agri-food systems. And the specific deliverables of that reference architecture are a set of terms and definitions so that we are talking about the same things. A thing called the business capability model, which is a way, sort of a map of the kingdom, if you will, that divides the whole space of data-driven agri-food systems into all the different things that an organization that does something in this space needs to be able to do, like send data out to, send work orders out to a machine, process work records obtained from a machine. All these different things that we've been talking about. And also developing, there's a misspelling there, a library of use cases that we can use in our standards. So those are the deliverables. And another important part is that inclusivity, in that it provides new stakeholders a way to experience the ISO process and to join the community without too much difficulty. And we've had folks from organizations or countries that weren't P members at the time, Botswana, Egypt, Sudan, and so forth, and from Nigeria, when it wasn't a P member, join IWA 47. I want to believe that that had something to do with Nigeria being a P member now. A couple of quick sort of parting notes, right? And like Ibrahim says, if you have any questions, please just unmute yourself and ask. I've been going a little slower than I thought because you weren't asking me a lot of questions. So I've been inventing questions along the way. So this is a little model developed by a very large Indian software company called Infosys, where they're thinking about the things, what it takes to implement AI, right? And the full article is there behind this link, right? So these 7 different items at right are enablers of AI implementation. So you need to have a lot of data, right? Whether because you're going to annotate it and do some form of supervised machine learning, or just because you have a lot of data that you want to find patterns in and so forth. But you need a lot of data. You need a lot of computing power, right? And now there are cloud options. And if you're very careful in choosing the right problem, right, the computing power that you need might be reduced. I have actually seen this in action, where we're making tools to estimate corn yield just with your phone. And for example, if you force your phone to be horizontal when you take pictures of the rows, it's a lot easier in terms of computing power to train and to actually calculate your plant density, for example, right? Of course, don't underestimate the power of your professional's expertise, and standards can help with this, okay? Now, I know for a fact that Nigeria has invested a lot in obtaining some of this awesome math talent and engineering expertise and industry-specific expertise that this calls for. So I think you're well set up to succeed in this. A sort of parting note, back to this. Let's talk about ISO 42001 for a moment. It might be a good starting point. This is a management system standard for AI. It's an ISO IEC standard, so it was done jointly. It's for artificial intelligence management systems. It's pretty new. It provides a framework for organizations to develop, deploy, and manage AI systems responsibly. And there's a long list of things that it enables that are necessary for an organization to be able to take on the responsibility and at the same time reap the benefits of using AI to solve problems. It ensures that these organizations' AI systems are trustworthy, reliable, and aligned with global standard best practices. And here I put a little link where you can start looking at that, right? You might ask, when you follow this link, you'll see these standards are not free, right? And you'll say, well, wait, why do we have to pay for these things? Well, it's because unfortunately, standards bodies all over the world, including the international ones, but the national ones too, have to sell standards as a way of making ends meet. For most standards bodies, the sale of standards covers over half of their budget, right? But if your organization thinks that spending, say, $100 on a standard is too much money, imagine how much money it is to have to reinvent the wheel, only to see later that it doesn't work in the bigger context that you would like to be able to exchange data in. So this is an important matter. So why should Nigeria care about all this? Just some examples very quickly here, right? That lead to essentially food security and being able to build your rural economy and transition so many smallholders to having better food security, having more stable income and so forth, right? Through things that we've talked about already that echoed throughout the presentation, filling gaps in agricultural extension with AI-assisted tools, dealing with climate change, mechanization and technology adoption, risk management, providing them direct access to markets, and so forth, right? So what I would like from you is look for ways for Nigeria to participate actively in the international standardization system in general, and ISO TC 347 in particular. There are some thoughts here about how that can happen. If you want to get a taste of the system, join IWA 47. Registration and participation are free. And of course, I would ask you to follow TC 347 on LinkedIn so you can know what's going on. And with that, thank you very much. We have any parting questions? I think we're almost at time. Does anyone have any final questions? And I apologize that we started a little late here, but I'm happy to stay a few minutes over if somebody wants to ask a question.
If you do have a question, you can freely unmute yourself and ask. Thank you.
Okay.
Oh, somebody's saying that they can't unmute.
Okay. Thank you so much, sir. I've been trying to unmute myself for a while. I was a co-host before, but I changed my platform, so I've been issues unmuting myself. I want to thank you so much for that power-packed lecture. It was very wonderful. I learned a lot from that. And like I said, this is one of the best platforms you can share because as ICT engineers, we're meant to look at all these issues we talked about and not just study them, but also provide solutions, technological solutions, because they're not just meant to think about hypothetical, solutions, but bring the real world solutions in play. And so we thank you so much. I think you deserve a detailed applause like we usually do for our facilitators. Please let's give Engineer Ferreryra detailed applause for that wonderful presentation. We appreciate you, sir. And we mentioned that if anybody has questions, contributions to make, please, the floor is yours. I have mine about if there's anyone with theirs first before I go ahead. Okay, in the absence of that, I think I'll go ahead. Personally, agriculture has been a great subject to me and my family. And I'm from a family of academias in agriculture. My mom is a professor in agri-economics. My dad, professor of forestry and wildlife. And, that's why I had to quickly send that link. I can see on the call. Hello, Mom. It's good to have you here. And so it's even in my master's, I also did smart agricultural systems. I think is a very good one. And you said something. You said farming involves hundreds of decision making. You know, looking at the question that Mr. Ibrahim mentioned the other time, mechanized farming and having the other way, AI and all that. I think one of the key things we need while looking at the mechanized, which has been part of the industrial revolution, is helping the decision making of farmers. Very important, very important. And so I latch on that, sir. And so some of my question now is, you showed the part where you looked at the data producers when it comes to having standards and non-standards. So how do we ensure we have structured and standard data? You know, I'll give an idea that I have. I came across this article about this young billionaire, this self-made billionaire on the Forbes list now. Forgotten his name now. He's into AI, and his major services is data labeling for training, you know, AI systems, data labeling.
Mhm.
So I'm just asking, is that kind of service needed? You know, when you mentioned IWA 47 about building a repository of information, and you know, if that is something, and how do we go about that? And if we look at maybe a more top-down approach, what can be our national approach to ensure a data-driven agricultural sector? Can you just give us a
Well,
few on that? Okay, so I'll leave it at that first.
there's several aspects to that. On one hand, yes, data labeling is very important when you're doing things like supervised learning or reinforcement learning, right? Which a sizable fraction of current practice in AI uses to a greater or lesser extent, right? Even like DeepSeek, the you know, the newest entry in the large language model arena, even that uses some supervised learning and data labeling. So in fact, the better that we label data that's used to train models, the less these models are likely to hallucinate and give a user the wrong answer, right? So collectively, we have a strong incentive for that. And there are ways to be able to use AI tools and other tools to make labeling easier, right? And we also have to just have a conversation about what kind of labeling approaches are best for the kinds of data that that agriculture and food systems employ. For that, TC 347 has a group called Ad Hoc Group 5, where we're looking at exactly that question. It's led by, I don't think he's a billionaire, but a pretty young millionaire, I'd say for sure, a German AI enthusiast who's very passionate about that kind of answer. So, or question. So that's very important. Now, thinking about how a country can go about capturing this value, right? First of all, be aware of what is out there and look for ways to use it. For example, Amazon pioneered a service called Mechanical Turk, which is a way of crowdsourcing data annotation. I've used it with, for example, a kernel counter to count corn kernels on ears of corn, and for the stand counter that counted corn plants in a photo, where you pay people to go and mark those things for you, right? Getting organized to do those things nationally and involve people nationally is probably a good way to go about that. And that space has moved along quite a bit since the time when I was doing that a few years ago. There are a lot of tools out there. Get your universities involved, use them as poles of development. Look at this idea of platforms of diffusion of innovation that TC 347 is also thinking about, and as a way of making like your research money go a lot further, right? And then also look at some of the standards out there and establish some priorities about what you would like to move on first. Like that ISO 42001, I pointed that out by name because I think it might be a very good start for Nigerian organizations to put in a set of standard best practices very early in the game to guarantee success. There's several other standards like the new ISO 7673 series, for example, that can help represent agricultural data unambiguously in a way that that can be exchanged freely, right? Also, I'm seeing that people are having some trouble unmuting. So raise your hand. I guess our admin can unmute you.
Okay, so one more question before the next person.
Yes.
I wanted to ask the sources of data, the tools that will be used. Are they going to be isolated per category? Maybe you talk about big machineries. If small older farmers will be set aside. Why I'm saying this, I'm part of this TC 77, which is electromagnetic compatibility. And I remember when we were talking about how to measure the electronic, the magnetic field interference. At that time, I was trying to let them know that there are new tools, mobile tools that can be used to take these readings. And I remember the chair saying there that no, now we're not looking at that. We're still looking at all these conventional, tools, olden days tools. But I believe what some big tools can use, mobile phones can do them now. Are you going to segregate, tools, the type of tools where you receive data from, or you try to get data from all sources? And so just an idea, sir.
So if I understood the question, you're asking about sort of best practices for obtaining data to drive those insights and so forth. There's a saying which is garbage in, garbage out, right? Which is very true. It means that if the data that you are using to drive your decisions isn't very good, then the result of that decision making isn't going to be very good either, right? And I was having a conversation earlier today with another ISO group about the importance of paying attention to data quality. And that is a central concern of TC 347. And I had the opportunity to talk today with the people who decide on the data dictionaries that come standardized off of machinery regarding the ISO compatible machinery and the variables that they're collecting values for. And I think there's movement to slowly there's movement in the agricultural industry to pay more attention to data quality. Again, in TC 347, we have another ad hoc group 7, which had its first official meeting even earlier today, that is dealing with the idea of how to help people get to actionable insights with data that come from machines. Right? Because I showed in that little workflow that there's all these sort of pain points, right? Most of those pain points can be worked around if you have the proper workflow. It's just complex for a grower. Like you mentioned, farmers are getting old in many places, right? And not very, friendly to the idea of dealing with data and learning all these new things. So if we have standards and guidelines in place of how to set up those workflows so that we can ensure good data quality, then things will start getting easier in general, right? It was a long-winded answer. I'm sorry. I hope it helped.
Super helped, sir. Thank you. So, any more questions?
Yeah,
Contribution?
hello,
Okay.
can you hear me?
Yes.
we can.
Okay, yeah, thank you so much for that beautiful presentation. I really got a lot of new information. I'm really interested, to hear that you mentioned the ISO 42001, because as I'm a machine learning engineer, and this is the first time I'm hearing about a specific ISO standard for AI management systems, and I think it's going to be very relevant to the work I do at my organization, in ensuring responsible and robust AI deployment. But on a slightly different but related note, considering the recent establishment of ISO TC 347, focusing on data-driven agri-food systems, I was wondering if you could share some of the early quick wins or tangible progress the committee has made in establishing data standards for this sector.
Okay. So this committee is very young, right? Our first plenary was 1 year and 4 days ago, right? So as far as ISO committees go, it's very young, and getting a standard out the door takes more than 1 year. Okay, so what I can tell you is that we've had success in bringing a lot of the right people to the table, and there's a lot of excitement that we currently have 7 different ad hoc groups dealing with different aspects of standardization that range from greenhouses to the semantics of how to come up with a common list of crops for the whole industry that everyone can map to integrated pest management, to AI annotation, to livestock activities tracking, to this business of getting insights from actionable data. There's groups on communications, on stakeholder engagement, and on responsible innovation, because we take that very seriously. It's a pretty novel concept in an ISO standard to have an advisory group dedicated to that. And we've got easily 10 more things that are orbiting very closely, just sort of that we're working on setting up, like tracking manual harvest of fruits and vegetables and things that are picked manually or by a robot, for that matter, individually. More smart irrigation, building upon the 7673 Part 3 and so forth. There's just a lot going on. There's a lot of excitement. I think the biggest win has been that people are excited about the opportunity. At the Berlin, somebody who was close to the organization of the Berlin plenary but missed it was very disappointed. And she said, my perception is that I have lost out on a once-in-a-lifetime networking opportunity. right? And the truth is that every meeting is a networking opportunity. So if you're interested in this space, I would suggest that you speak with your national standards body and with the organizers of this event to find your way into the space. And I'm, happy to talk more about that, soon.
Yeah, thank you so much.
There's a question about how would someone access the recorded presentation? I'll leave that in the capable hands of our organizers. I will send the slides to them so that they can distribute them as well. And any other questions?
I have a question.
Yes.
Okay, so with how long does it generally take to develop a standard? That's one. Secondly, in the course where the third world or the global south is struggling with things like access to energy, electronic systems, how best do we key into application of standards to our agricultural sector, right? Before becomes a business, we have to have the agricultural sector at least lifted up to some extent. So to the ICT engineers, if we're looking to provide solutions in the field, what would be your suggested areas of concentration?
That didn't sound like a question for me. Or was it?
Okay. So in question form, what are the immediate areas of attention that ICT engineers or solution providers should look into to help us incorporate standards into our agricultural sector?
Okay. I will answer that, and I'll answer something else that you implied but didn't actually ask, which is which has to do with resource limitations, right? So a country in the global south has to allocate its resources optimally, right? Because those resources are limited. How does that intersect the whole standardization space? Well, in great part, it involves making sure that you muscle your way to the table and you sit at it and you make sure that your concerns are heard. For example, the energy efficiency of AI is a very big deal. I was talking recently with someone who was who wanted some guidance on how to set up an AI system that they were wanting to set up, and I pointed out that the costs of cloud computing, for example, could quickly spiral if the system wasn't designed carefully. In the same way, energy use can spiral out of control if not managed carefully, right? So part of what you should do is make sure that you have a seat at the standardization tables to make sure that there are requirements in place in standards about things like paying attention to energy and tracing energy uses and making sure that your AI management system is mindful of energy costs, right? I don't remember seeing energy costs in 42,001. It might be there. I haven't, gone through it with a fine-tooth comb, but I wouldn't be surprised if it wasn't. And that might be because there weren't enough people from the global south sitting around that table, right? So going back to the sorts of things that a country can do to incorporate standards into your agricultural sector.